So as part of Mission Sustainable Growth and later Green Core rating system came about life cycle assessment, we realized that a lot of companies outside of India were using life cycle assessment as a tool to innovate, as a tool to measure their environmental performance, as a tool to assess at which stage of the life cycle the maximum impact was occurring. So CI has been working on life cycle assessment for the last few years. We conduct life cycle assessment studies for companies. We are also partnering with EcoInvent Center, which is based in Switzerland, on collecting India-specific data sets. So these can be uploaded in the software and then used by other companies. We conduct a lot of trainings, workshops, and webinars like we are today to create awareness. We publish newsletters. We have a website on LCA that should be updated more often, but we also have some information on the website. We are also working on building the LCI India network, and we are doing a lot of awareness through Green Core. So that's sort of our work on life cycle assessment. Now, what is life cycle assessment? We'll move on to the next part of agenda. What is meant by life cycle assessment? Now, what I'm going to do is I'm going to show you this photograph, and I'll give you a minute to just look at the photograph and try to contemplate what is the message the photograph is trying to give. I'll give you about a minute to just look at the photograph and contemplate what is the possible message that this photograph is trying to give. So I'll give you about a minute. Normally in trainings it's easier to interact, but so the message that this slide is basically trying to give is, you know, what you see in the photograph is a guy that is proposing to a woman, but there's a huge bag on his shoulders that is pulling him back. Can you type and tell me what is the possible message that is, you know, happening here? What is the message of this photograph basically? Does anyone want to type an answer? I have the chat box in front of me, open in front of me, so if anyone wants to type a message and tell me what is the message that the slide is trying to give, then you're more than welcome to. Nobody wants to try giving an answer? No problem. So what this photograph is basically trying to say is that, you know, even something as small as a ring, when we go to the grocery store to buy biscuits and our groceries, we have coffee every morning, we use a toothbrush every morning. There are little things in our life that we use daily, but we do not know what is the environmental impact of that object. So what this photograph is trying to say is that this man is proposing to a woman. However, even the environmental impact, the load of the ring is so huge that it's pulling him back. So he is not able to stand on his legs because the environmental load of the ring is that high. Normally when we buy an object, when we use a particular product, we do not know the environmental impact of the product because the environmental impact of the product is hidden. And what life cycle assessment aims to do is to bring to light what is the environmental impact of that product. So it's not hidden. So LCA is basically a holistic yardstick of environmental performance. So what you basically have here is you have your raw material extraction stage, you have your manufacturing production stage, you have distribution transportation stage, you have your operations maintenance stage, and then you have your recycle waste management stage where your product finally reaches the landfill or incinerator. At each of these stages, what is the input going in and what is the output? That's what life cycle assessment helps us to do. So life cycle assessment is defined as a method or a tool for the estimation of environmental and human health impacts that are connected with a product, or it could be a service, or it could be a process, or it could be a technology over the whole life cycle from cradle to grave. Now, LCA is really found everywhere. For example, if you were to take the national voluntary guidelines that came out by the Ministry of Corporate Affairs, Government of India, they very clearly say that businesses should work on providing goods and services that are safe and contribute to sustainability throughout their life cycle. They have very clearly mentioned that companies should consider doing life cycle of their products to understand at each of the stages during the life cycle of a product, what is the impact on the environment. Then you also have the Consumer Goods Forum, the Sustainability Consortium in the US that has come out with a matrix for understanding the impact of different packaging materials across the life cycle. Then you have the Greenhouse Gas Protocol Initiative by the World Resource Institute that also very clearly outlines when you talk about doing the carbon footprint of a product, you're considering different life cycle stages of that product. So that's where LCA has come out. Then you have environmental product declarations. There are many products that have eco labels on them, and that also involves doing a life cycle assessment. Then you have the Grenelle Act in France, which came out in 2011 that clearly says that all high volume consuming products should have done a life cycle assessment study and publish the results of the LCA study on the label. So just like when you walk into a grocery store, you can see the nutritional attributes of your, whatever that you're about to eat, any edible product, you also should be able to see the environmental footprint of that product. In 2003, there's also integrated product policy that came out in Europe that focuses a lot on life cycle assessment. So life cycle assessment is really has its presence everywhere, and it is extremely, I can say, a crucial regulatory procurement, design, and marketing tool that is increasingly being used by the government, by the consumers, by industries. Now, these are some of the companies that are doing LCA, India and outside. Just to give you a feel of how it has touched every corner of the world and every sector, from FMCG to paper to cement to chemicals to electronic devices to engineering companies, cement companies. It sort of touched every sector. So a vast number of companies across the globe are doing life cycle assessment. And what are the uses of LCA? Now, LCA has many uses. It can be used as a decision-making tool by the government. For example, if we were to consider two scenarios where you have the option of using an electric car, that is, the batteries are charged by solar panels, or you have a car that runs on biofuels. How are you to decide which is better for the environment? They both sound green. One is solar, electric, then the other is biofuels. So if the government were to decide which technology it should promote, which technology it should subsidize, which technology it should give incentives for, it can then use a life cycle assessment tool to find out the actual environmental impact of these two technologies, to compare these two scenarios. And that's when life cycle assessment can help in decision making. Then you also can use life cycle assessment to drive innovation. This has happened, we will share later during my presentation. I'll show you case studies where life cycle assessment has helped in driving innovation. It can help you identify areas for improvement. It can also be used as a marketing tool. For example, if you have now manufactured a product that has a 50% less carbon footprint, then you can use LCA, the results of your LCA study, to show how your product now has a reduced carbon footprint. So it can help support your marketing claims. It can help you in all sorts of PR. There's also helps in design for environment. A lot of designers and other scientists believe that sometimes 90% of the impact of a product is during the design stage, especially products that have a high environmental impact during the usage phase can reduce the environmental impact by changing the design such that it uses less energy during the usage phase. So when you do an LCA study, I'll share case studies a little later about how LCA comes in when we talk about design for environment. It can also help in benchmarking. When we talk about 1 kg of cement or 1 ton of paper, if all the big manufacturers, all the small manufacturers were to do a life cycle assessment study, we could come out with benchmark data, which is the greenest paper, which is the greenest cement. We also have environmental product declarations. We spoke about eco-labels. Life cycle assessment is required if a company wants to get an environmental product certificate, environmental product declaration. So it has many, many applications, many benefits, and the case studies that will follow will prove that. Now, talking about history of LCA. Now, LCA sort of started off in the 60s, and Coca-Cola was a company that started to do LCA in the US, and the idea was to sort of compare the benefits of using glass bottles which are not disposable versus plastic bottles which can be disposable. So earlier, the initial years, LCA was done primarily to understand the pros and cons of disposable products versus reusable products. And that's how it started off in 1969 with Coca-Cola trying to understand the impact of the packagings they used. And in the 1970s, what basically happened was the US EPA, which came out with REPA, which is the Resource and Environmental Profile Analysis, for again packaging material as well as waste. So the US EPA then took it over in the 70s. Then there were a lot of these ISO 14000 standards which are coming out. So in 1996, the ISO 14040 standards came out for LCA, and in 2002, the Life Cycle Initiative in LCI was launched by the United Nations along with Society for Environmental Ecology and Chemistry, CTAC, and today we have n number of companies, consultants working on life cycle assessment, and we've already seen how many industries have done life cycle assessment. But it all started off with companies trying to understand the impact of packaging material, of waste that was being disposed to landfills, and then it sort of spread to other sectors as well. And the ISO 14040 standards came about in 1996. Now, there are different types of LCA. You have what you call the basic screening. So basically what happens is, if you need a quick answer, if you have a very small budget and time is important, more important than your precision, then you can do a quick screening which will take maybe a few weeks to do. And the next type of LCA you have is basically a short internal LCA study. If you do not want to communicate your LCA results to the outside community, for external communication, for your sustainability reports, if you do not want your answers, your study to go into the report outside, then you can do a short LCA study which might take you maybe 10 weeks, 10 to 12 weeks. And you can also do extensive studies which will take anywhere from 3 months to maybe even 3 years, depending on your product. If you're actually trying to find the details of any environmental claim, if you want an independent review from a third party, from an expert, and then it's an extensive study that takes time. And you can also use LCA for your continuous LCA operations. Every year you can sort of integrate it into your environmental life cycle management information system, and that way you can use LCA on an ongoing basis every month, every year. Now, so this sort of gives an idea. I hope I've been able to clearly articulate what LCA is. LCA is basically a tool. It's a software that is enabling you to quantify the environmental impacts of your product at each stage during the life cycle. Now, how to do LCA? In LCA, you know, we have 1-day trainings in LCA, we have 2 days trainings in LCA, but I'll try to summarize as much as I can, you know, in a few minutes of how LCA can be done. So there are 4 basic stages on how life cycle assessment is conducted. So the very first stage is goal and scope definition. The second stage is life cycle inventory. The third is impact assessment, and fourth is interpretation. So to explain what the first stage does, the very first thing that you would need to do is scoping of LCA. The very first stage involves doing your scoping of LCA. So what is your goal? Now your goal should ambiguously state what is the intended application, what is the reason for carrying out the study, and who is the intended audience. That's what you need to decide in your step 1. Why am I doing an LCA study? So some of the goals, for example, could be, do I want to understand the environmental impact of my product? Is that my intention? Or do I want to understand where the impact comes from so I can improve myself, I can reduce my environmental impact? Or is my intention to provide information to my customers? Is that my intention? Do I want to market environmental virtues of my product? Is that my intention? Do I want to compare my product with other products? Do I want to enable my consumers to be able to compare my product with another product? Is my product superior to another product in the market? So what is my goal? I have to be extremely sure of that before I start off my LCA study. Next, you will have to decide who is the audience that you are talking about here. So is it designers? Is it other businesses? Who is the public? That's again part of your step 1. Then what else is part of your step 1 is a very important component, which is system boundary. When we talk about system boundaries, we are talking about what are the different stages in your life cycle. The very first stage is raw material extraction, where you're mining your raw materials for making your product. Then it goes to the factory for manufacturing. Then you transport your product. Then you might transport it to another processing industry or to your consumer. Then you have the usage phase when your product is actually used. And finally, you have the disposal phase. Your product is disposed or it is recycled, which is also a possibility. So at all of these stages, which stage are you going to consider for your LCA study? That's something that you need to decide at step 1. So here are the different options. You have cradle to gate, you have cradle to grave, you have cradle to cradle, you have gate to grave, you have gate to gate. So there are different options available to you for doing the life cycle assessment study. Your cradle basically means the very first stage, raw material extraction stage, and your grave is your landfill, and if you want to recycle, reuse it, then you consider cradle to cradle. So you will have to define, at the very first step, you define your goal, why you want to do a life cycle assessment study, who is your audience, and what are your system boundaries. And once you've done that, the next aspect is your flowchart. So let's say, I'm doing the life cycle assessment of wooden chairs. So then I'll have to do a flowchart of each of the processes during different stages in the life cycle. What are the processes involved? Again, this is from cradle to grave. So I grow trees, I harvest trees, I get the wood, and then I also need electricity. I also need diesel, so I need to extract petroleum. I also need to make glue and other fasteners and to make varnish. all of that is represented in different process stages here in a rectangle. And then you also assemble the chairs, and then you transport, use, and then you dispose of the chair. So this is how a cradle to grave life cycle assessment is done. So this is the flowchart for which defines the system boundaries and shows the processes. So for each of the rectangles that you see here, there is a process and represents a process. So what is the input to each of these processes? What is the output of each of these processes? That's what life cycle assessment will do. So coming to that, I'll give you a small exercise. I hope all of you have a book and a pen handy. So what you can basically do is you can just pull out a paper, pen, and it's a small exercise. So in order to evaluate if bottled water in plastic bottles has a higher or lower environmental impact than glass bottled water, you will do a life cycle, comparative life cycle assessment study. And in order to do that, your goal is defined. It's a comparative LCA study. And now you'll have to do a flowchart for it. So why don't you go ahead, I'll give you about a minute or two, so you can go ahead and do a flowchart for, just spend a few seconds thinking about what your flowchart will have. You're going to do a flowchart from cradle to grave of the two alternatives of bottled water. One is plastic. So you will start off by thinking where plastic comes from, where is plastic then processed so the bottle is formed, and then it is transported, and how is it disposed or recycled. And similarly for glass, where does glass, the raw materials of glass come from, where is the raw material extraction stage, how it is sent for processing for making glass bottles, how it is then transported, what is at the end, at the grave, what happens to a glass bottle, is it reused, recycled. So all of this you will have to put into the flow chart. So basically, like the slide earlier had shown, you will have to do a similar flow chart for two processes because it's a comparative LCA study. One is for manufacturing of glass bottles, the other is manufacturing of plastic bottles. So why don't you go ahead and do a flow chart for these two. So it's basically very simple. You will have to draw a rectangle for each process, like was shown in my earlier slide. Each process during the different life cycle of the bottle, you'll have to put a rectangle. So I'll move on to the next slide. So after you have defined your goal, you have defined your audience, you have decided your system boundary, you have sort of done a flowchart of your process. Now the next aspect is functional unit. You'll have to define your functional unit. So what is a functional unit? A functional unit basically depends on the goal of the study. It is a measure of the function of the system that is being studied. For example, if you were to take paint, what does a paint do? Your functional unit will be the paint that is used for painting 10 square meters of this wall space that will last for 10 years. That's what I want to do a life cycle assessment study for. Or you could do it for 1 ton of steel manufactured, or for one particular car that I'm manufacturing. What is the impact? What is the result of my life cycle assessment study? So it will depend on the goal, whether it is a comparative LCA study or it is a study of your product. So that's what the function unit will depend upon, and it will also give you a reference for actually getting your information, for getting your inputs and outputs. It will give you a reference. It will also enable comparison for 2 different systems. So that's what functional unit does. A functional unit, if I'm a paper manufacturer, could be 1 ton of paper. If I manufacture cell phones, it could be 1 Micro Max iPhone model Q501. It could be, if I'm manufacturing plastic bottles, the functional unit could be 1 liter of water in a plastic bottle. What is the impact during the life cycle? So functional unit will basically depend on the goal as well as the function of your study. What is the function of your study? So if we were to take the previous example, if you want to evaluate bottled water in plastic bottles has a higher or lower environmental impact than glass bottled water, you are asked to do a life cycle assessment study. So then why don't you go ahead and define the functional unit for the study? Maybe you can take a few seconds to think about what would be a functional unit for my study if I were to do a life cycle assessment study comparing these 2 options of plastic versus glass bottles. What could also be another example is, earlier we spoke about how a government has to decide whether it wants to support or promote electric car versus biofuels. So in that case, the functional unit could be, one option is it could be per passenger per kilometer. I want to find out what is the impact on the environment. What is the life cycle assessment study results for per passenger per kilometer? What would be the results? So similarly, for this study, what do you think would be a functional unit, a good functional unit to have? So you can spend a few seconds and then write down in your notebooks. Now, after we are done with the first step, where we have done the definition, we have defined the goal of our study, the intended audience, the system boundary, the flow chart, and the functional unit. All of that has been covered in step 1. Now in step 2, what we need to do is what you call the inventory analysis, and this stage in the life cycle assessment really takes the longest time. Inventory analysis is nothing but that phase of LCA which will involve the compilation and quantification of your inputs and outputs for a given product system throughout its life cycle. So you have a process, you have different inputs going to the process, you have outputs, emission to air, water, soil, waste. So at input and output, for each of the processes that in our flowchart, we have different rectangles representing different processes. So what is its link with the environment? What is it emitting to the air? What is it taking away from nature? What are the resources it is consuming? That's what you'll have to quantify, compile, and put into a software. So it's the data collection of all the activities that you'll have to now document. What is the environmental load in relation to your functional unit that you have decided? Now there are different data sources. Your company, your own processes, you can get the data. But a lot of times you will also have to, when you're looking at your upstream and downstream activities, when you're looking at what happens outside of your factory gate during the raw material extraction stage, other processing stages, the usage phase, disposal phase, you will have to get in touch with your suppliers, with your customers to get information on what is the input, what is the output. You'll have to get in touch with waste management companies. There's a lot of published LCI data that you will have access to. There are a lot of publicly available reports. There's literature. There's also technical experts that you will talk to. So this is why it takes time, because you need to compile all of this information. And earlier I spoke about EcoInvent, the organization that we are partnering with. They have a data set for about 4,300 processes. So when you buy a software, you get access to these processes that you will now use as input to your system. And what CII is trying to do with EcoInvent is to establish this data set specifically for India. So right now, if you buy softwares, you get data sets for Europe and US and other parts of the world, but you don't have India-specific data sets. So what we are trying to do is establish these national level data sets for India. So if someone is manufacturing steel in India, someone is manufacturing paper in India or cement in India, or manufacturing brakes or tire in India, what is the impact on the environment? So when companies want to do a life cycle assessment of their product, they can then tap onto these resources. They don't have to go to the steel manufacturer, they don't have to go to the paper manufacturer, they don't have to go to the tire manufacturer to get this information. They can just buy the software and have access to that information. So that's something we are working on at the moment. So data sources, this is where you will get all of your information from. There's a lot of planning that is required when we talk about data collection. What will happen is which activities require site-specific data, which activities average data can be considered, which technology are we considering, should we talk to an expert, how do we handle confidentiality of our information, will the data suppliers get an opportunity to see how we are interpreting their data. So all of these things have to be thought about when you do a life cycle assessment, so stage 2. This is just to give you a feel of what a questionnaire will look like. So for example, for manufacturing steel, what you'll have to do is you'll have to take, let's say for in a year, how many tons of steel do you manufacture? That you'll have to ask. And then what is the coal, natural gas, oil, wood that is being consumed? What is the electricity consumption from the grid, from other power sources on site? What is the water consumption throughout the year? All of this information you'll have to obtain. And then what are the other materials that are being used? Pig iron, iron scrap, iron ore, manganese, limestone. Then what is, so all that is, so this previous slide and this, half of the slide talks about input. Now what about output? What are your emissions to air, carbon dioxide, carbon monoxide, other dioxins, SOx, NOx? What is the wastewater generated? What is your EAF, slag? All of this information you will have to fill in either for your own process or for your upstream, downstream activities, whatever it may be. This gives a sample data inventory sheet of Tata Chemicals. So we had organized a workshop in Hyderabad in 2011, and this is a snapshot of the inventory, what it looks like once you feed it into the software. Now, after all of the data collection has been done and fed into the software, the third stage here is we have the life cycle impact assessment. So it basically describes what are the environmental consequences of the environmental loads. That is what you're going to quantify. For each of our processes, what is the impact on climate change? What is the impact on the certification? What is the impact for eutrophication, for photochemical smog, for fossil fuel depletion, for human toxicity, ozone depletion? What is the impact of the processes of my activities on all of these different environmental loads? And one of the biggest advantages of life cycle assessment, I should mention here, is that it avoids burden shifting. You know, because it is such a holistic yardstick for measuring your environmental performance, any environmental burden cannot be shifted from one life cycle stage to another life cycle stage, from one process to the other, because it's all compiled here and put together. So this is the most interesting stage, because now you see the results of your study. So we have something called the global warming potential, which is basically, you know, it's a ratio of what is the increased infrared absorption which will be caused by one particular gas, the increased infrared absorption caused by 1 kg of CO2. It's calculated over different time frames. So this is a very potential contributor to climate change. So you have this method that is calculated by different softwares. Then you also have something called the ozone depletion. So basically in the stratosphere, You have about 15 to 40 kilometers above the surface of the Earth, you have ozone, which protects the life on Earth from absorbing the UV radiation. But because of the halons that are used in fire extinguishers and methyl bromide that's used in pesticides and other CFCs that are used in refrigerants, there's a lot of damage done to the ozone layer. So that is also quantified using life cycle assessment. Then you have something called acidification, which is what happens is because of the increase in gases like sulfur dioxide and nitrogen oxide, there is an increase in the pH value of precipitation, which is as a result of it, acidification happens. And that is also one of the impact assessment methods used in LCA. Then you have something called eutrophication, or which is basically what happens because of combustions and effluents, and because of the excess of nitrogen and phosphorus in the soil and in our water. There's something called eutrophication that is measured. And you have human toxicity, which is measured in 1,4-dichlorobenzene, and ecotoxicity, which is the continuous toxicological impacts on water and soil, that is also measured. And then you have photochemical oxidation, which is smog. What happens, there's a lot of, there's a photochemical reaction that happens of nitrogen oxides with hydrocarbons and volatile organic compounds as a result are formed. So what is the result of my processes on smog, on photochemical oxidation, because of which I think more than 1 million people suffer in Asia because of smog. So smog is again a very important category that is measured in our life cycle assessment study. Then you also have land use. For any activity that we use, the land use pattern changes. We transform the land from its natural state, so that has an effect on climate change. It has an effect on our species diversity. So that is also another category that is measured during using life cycle assessment. So this is an overview. These are the different life cycle impact assessment categories that different softwares have that we measure. The different softwares available on the left, what you see is CIMAPRO, Gabi, Umberto, OpenLCA. On the right, what you see is LCIA methods. So you decide which method. Recipe, RECIPE is one of the most commonly used methods today. So all of these methods are part of your software. And when you decide what software you want to use, these methods are inbuilt in them. So all of the information that you collected in step 2 is then analyzed in step 3. And what happens in step 4, which is your last stage of life cycle assessment, is basically using ISO 14040 standard defines it as the phase of LC in which the findings of either the inventory analysis or the impact assessment or both are combined consistent with the defined goal and scope in order to reach conclusions, recommendations. Which basically means this was what I started off with. In step 1, I had said this is my goal, this is my intended audience, this is what I want to do. At the end of the study, were you able to achieve your goal and scope? Were you able to reach any conclusions, recommendations? So that's the 4th stage. I mentioned about Tata Chemicals doing life cycle assessment study. So what they have done, this is a snapshot of the result of their study. What they have here is 3 products. They have DAP, they have urea, and they have ammonia. So you see DAP in green, urea in red, and ammonia in blue. And what you see on your x-axis are the different environmental impact assessment methods that we discussed earlier. You have, if you were to consider global warming potential, you will see that impact of DAP is much higher than the impact of urea or ammonia. If you were to consider human toxicity potential, it's more or less the same. Again, if you were to consider ozone layer depletion, the impact of DAP is so much higher than the impact of urea and ammonia. So this is just to give you a feel of what kind of results you can obtain when you do a life cycle assessment study. These are some graphs that you will get at the end of your life cycle assessment study. Then what you also have is sensitivity analysis. So what basically happens is sometimes you're not sure of some information that you get from your upstream, downstream activities. The variation is maybe, the value you get might be 20% higher or lower. The value might be 80% higher or lower than what you expect. So what you basically do is Monte Carlo compilation. You do a sensitivity analysis that, let's say the energy that you were using for a machine, the literature says, X kilowatt hours, but what if it was 50% more? What if it was 200% more? How would my results change? So the software enables you to do all of these analysis to see how your output changes when your input changes. And if your input changes, how does it impact on your output? So both ways you can see what will be the impact of your product or process. So that's how a life cycle assessment is basically done. There are 4 stages that we discussed. Again, we can have a detailed training on how these 4 stages are carried out, but just to give you a summary, it's you define your goal, you define your functional unit and your system boundary and your flow chart, and then you decide, you have to collect all of the information, compile the information, feed it to a software, and then the software will give you results in terms of different environmental impact methods, and then you have interpretation and recommendations that come out as a result of that. And then moving on to the next aspect of our presentation of our webinar today, LCA applications and case studies. So let's see what companies have done. Like I said, there are many applications from marketing to purchase to design to benchmark to your tracking of environmental processes to policy decisions. There are different applications of LCA, and some of these case studies that we're going to show, that I'm going to show you today, will prove the different applications. This is an example of a Swiss national park. On their 100th anniversary, they decided to do a life cycle assessment study. So you will see that with climate change as well as ecosystem quality, the spectators that came to their park for a concert or to visit their park had the maximum impact from 55 to 76%. Then the performers had the next highest impact, about 33% in climate change, followed by infrastructure. And organization had the least impact on climate change if they were to do a life cycle assessment of all of their stakeholders. And what were the learnings for the Swiss National Park? The learnings are basically, like I said, the spectators and performance contributed to a significant impact on environment, and that was because of transportation, how they chose to commute to the national park. So their environmental strategy as a result of doing life cycle assessment study is to actually give incentives to their spectators to take public transportation. So if their spectators and their performers, like a performer takes public transportation, they get reimbursed for their travel. But if a performer chooses to drive by himself or herself, they do not get reimbursed for their travel. So that was their environmental strategy to reduce the environmental impact from running the park, is to actually address where the majority, the major impact is, and that's transportation of the spectators and performers to their facility. It's also a big ecosystem quality impact came from the food that was consumed during the event, so how can that be reduced? And the study also said that since this stage was made of 100% local wood and it could be easily disassembled for future reuse, the impact of infrastructure that we see in the previous graph is less. I also wanted to bring to light a point here that whenever a life cycle assessment study is done, the assumptions that are being made are very, very important. What are the assumptions that you are making? Is your assumption that you serve only local organic food? Is your assumption that 50% of the commuters will take public transportation? So all of these assumptions have to be very clearly stated. And so the assumption here that is being made, and it's true, is that the stage is made of 100% local wood and is reused. So that's an example of how a company can use LCA to come up with the right environmental strategies. Another example is, I spoke earlier about history of LCA, how LCA was first done to analyze the pros and cons of different packaging materials. And this is an example of Sprint, which is an American company that does life cycle assessment of their packaging material. They manufacture phones. So earlier in 2008, they had something called a black box. Then they moved, 30% reduction in resource consumption. They moved to a white box, and then 50% reduction. 2012, what they had was a craft box. And what basically happens is we get all of these manuals with our phones that we do not always read. So they came up with a literature pack which weighed much less, which was much less. Because what is the life of the literature pack we get? We get the phone, we toss the literature in the dustbin. They also started using recyclable material for their packaging, and because the volume of the packaging material reduced by 55%, they could stock more boxes on the plane, and therefore fewer planes and trucks had to travel to carry the same volume of phones. And what life cycle assessment also enables you to do, these are the different impact categories they considered: climate change, human health, ecosystem quality, resource depletion, and water withdrawal. So life cycle assessment study helps you communicate this information in a user-friendly way. For example, because of the reduction in volume by 55–60%, what did Sprint achieve? It saved 8,800 megawatt hours of electricity. But what does that mean? That means you could light the Statue of Liberty for a year. Let's say you manufacture a product, you save energy, but how do you communicate that to a user? You can say you will light the whole city of Hyderabad for half a day. That's the amount of electricity you save. Or you could light the whole India Gate for about a year. So these are the benefits. This is how, using LCA study, you can actually quantify benefits to the consumer, to the external world, for communication in a very effective way. You can support your marketing claims. Again, how much water were you able to save? You saved 8,900 kilogallons of water, and what does that mean? It means 68,500,000 500 ml bottles. So that's how LCA can help you in communicating the benefits of all the environmental initiatives you take, the packaging redesign initiative which Sprint has taken here. There's a case study. I spoke that one of the benefits of LCA is design for environment. That's why Herman Miller's case study comes in. This is a snapshot. They're a furniture manufacturer. This is a snapshot of the inventory in the software for distribution stage, for your distribution stage, for end-of-life stage, for production stage, raw material stage. At each of these stages, what was the input-output to the system? That was quantified. And this is the results of this study. Basically, so what has happened is that what is the global warming potential? You will see that the raw material extraction stage and production stage have a high impact on global warming when compared to the distribution and end-of-life stage. And a raw material extraction stage is a much higher impact than production stage. Again, we look at acidification, eutrophication. It's the same trend. Raw material extraction stage has a higher impact than any other life cycle stage, basically. So what was the result of this study that Herman Miller did? So Herman Miller basically came to the conclusion that the major sources of impact is actually your raw material, right? Which the graphs earlier showed. So how can we reduce the product weight so that lesser raw materials are used? Material extraction is accounting for 80% of the impacts. What type of energy is used? So they have decided to engage with their suppliers. They will select only recyclable materials. They will establish a closed loop system so that the raw materials can be easily disassembled and reused in other products, and they will eliminate unnecessary packaging as much as possible, because it is in the raw material extraction stage where the maximum impact is. So that's how they use it as a strategy to come up with ways to reduce the environmental impact. This is a case study that was presented at the Green Co Summit in June of 2012 in Bombay. It's by a carpet tile manufacturer called InterfaceFLOR. And you will see in the graphs here how the raw material extraction stage has a 68% impact on the when you see the entire life cycle. Manufacturing, transportation, customer use, end of life has a very small impact. So that basically means their strategy to reduce the environmental impact is you manufacture a carpet tile such that you reduce the amount of yarn that you're using, or you reduce or you increase the recycled content of yarn, or you create a smarter yarn that has a lesser environmental footprint. Because the maximum impact we saw in previous stages coming from raw material extraction, from your yarn manufacturing, which was 45%, how do you reduce your environmental impact? You have these three strategies. So after doing an LCA study, they came up with a new cutting technology, which is the ultrasonic cutting technology, which cuts waste by more than 80, reduces the waste by more than 80%. So they've saved about 750 tons of CO2. So you will see in the graph, in the photograph here, how the amount of waste being, how the amount of material lost as waste from die cutting, and now the new ultrasonic cutting technology reduces the window of waste. They also came up with two new products. One is micro tuft, which is half of the normal yarn weight, so it weighs much lesser, so it uses less more materials, therefore has a lesser environmental footprint. You also have Biosphere, which has 100% recycled yarn, and therefore has half of the carbon footprint of a normal carpet tile. So these two products are now in their pipeline, and so the percentage of sales from these products is now going to increase year after year. So that's an example of how you can design your product differently such that it reduces its environmental footprint as a result of doing a life cycle assessment study. I also wanted to share with you about a very important application of life cycle assessment, which is very common and will become more and more common, especially in India. You have something called voluntary environment performance labels. Now they're basically classified into three categories. You have type 1, which is based on your ISO 14020 and ISO 14024 standard, where the overall environmental preferability of a product is very clear. So you have green seal in USA, you have green mark in China. A lot of countries have their own equal labeling programs. You have Blue Angel, you have Nordic Swan, where the environmental preferability of a product is very clearly said. If you're buying this housekeeping chemical, it is certified by Green Seal. It is a green housekeeping chemical. It is a green paint. It is therefore environmentally superior than any other product. So if you want such labels on your product, life cycle assessment becomes mandatory. Then second type you have is ISO 14021 type 2, which is a self-declaration. I am manufacturing a green product. I will declare it as a green product. It's a self-declaration. The third type is ISO 14025, which, for example, you have EPD, Environmental Product Declaration, which is basically a preset category. There's a preset category for each product, and based on that, you will publish the results of your LCA study. So just like you have, you buy a burger, or you buy a box of chocolate, a box of cookies, the nutritional information is available on it. But what about the environmental footprint? If such an information is published on a product, it is called an environmental product declaration. It provides relevant, verifiable, and comparable information about goods or services. What you basically have organizations where they have fixed, for each product, there are some rules that have been fixed. CIS is also going to launch environmental product declaration soon for certain products. So for each product, there are some category rules that are fixed. So a company has to do a life cycle assessment study which follows these rules. The information is compiled and verified, and then a product can register and use the logo on its product, basically. So that's a very, very important application for a life cycle assessment study. And this is a case study of an environmental product declaration, EPD, by a spaghetti company which is called Barilla, which is in Europe. So for their 500 grams box of noodles that you see here, they have done a life cycle assessment study. And they have considered different system boundaries. So they have considered cradle to grave. So right from the wheat that you grow to the milling process, to production of raw materials, to the paper boards that are manufactured, to the semolina that's made, that's given to the pasta factory. From pasta factory, it's bought by it's transported in trucks. There's some water cooking treatment that happens. You have to heat your water. Here it's Europe, so there are electric heaters there to electric stoves. They cook, and then the pasta is eaten, and the packaging probably is recycled. So end of life of primary packaging. So this is the system boundary that they considered. So this is the results of the LCA study. You will see how for global warming potential, so now there are different impact categories that we considered. Global warming, eutrophication, acidification, land use pattern, biodiversity, fossil fuel depletion. So for global warming potential for 500 grams of pasta, for different life cycle stages, you have your drum, you have your wheat that is grown, your semolina that is made, the pasta production, your packaging, your transportation, and your cooking phase. So you will see here that the cooking phase has the highest impact, about 400 grams for a 500 grams of pasta. That's probably because of the electricity that is consumed in heating the water that has a big impact. It will be interesting to find out what if you're using LPG, what is the impact. Then it will probably be wheat that is grown during farming. What has been the impact of pesticides, fertilizer use? That's probably very high, and that's why you see 454. And then the third highest impact is that of pasta production in your actual factory, where you see 166. So these are the kind of results that you can obtain doing a life cycle assessment study and then publish these results to share with your consumers. This is another case study by Vestas, which is a wind turbine manufacturer. This is again an environmental product declaration. Let's say you have, here again they have considered cradle to cradle. So manufacturing of your wind turbine, the different components, the blades, the cables. So what is the input to the system? What is the output to the system? What are the materials consumed, energy consumed, water consumed? What are the emissions to land, air, and soil, and water? And then during the erection stage, you need gravel, you need oil. Again, there's some emissions. During maintenance stage, what is the energy, oil required? You generate electricity in the usage phase, which is renewable electricity, and then in the dismantling phase, the end of life phase, again the steel is recycled. 100% of the steel is recycled. So in a lifetime, a wind turbine, which is 1.65 megawatt hours onshore, will generate about 118,000 megawatt hours in the 20 years. So what they wanted to calculate through the EPD is the energy balance. When does it cut off? How many days, weeks, months, years does a wind turbine have to run so it generates enough energy that it consumed in all of its life cycle stages? So basically the answer was 7.2 months. So within 7.2 months, the wind turbine breaks even. So when a wind turbine runs for 7.2 months, it generates so much renewable electricity that it actually consumed in all of its life cycle stages. So we all know that wind turbines are eco-friendly, are good for the environment, but doing an energy balance actually helps you come to a particular number, quantify 7.2 months I have broken even. A wind turbine also uses certain energy to manufacture, to erect. Solar panels also use some amount of energy for manufacturing, erection, transportation, dismantling, end-of-life treatment, all of that. So life cycle assessment study will actually help you find out when it breaks even. This is a case study of XLERATOR, which is an electric hand dryer manufacturer. They did a life cycle assessment study, and if you see the carbon footprint, they have done a comparative life cycle assessment study. How do I find out whether it is more eco-friendly for me to dry my hands in an electric dryer or to dry my hands using paper towels? Or if I have to dry my hands using paper towels that are made from recycled paper. So all of the four scenarios are compared. You have your XLERATOR dryer, that's the first bar. The second is a standard electric dryer, which is not very energy efficient. And then third, you have paper towels, and fourth, paper towels with 100% recycled content. So what you see in yellow is the usage phase. What you see in red is the manufacturing stage. What you see in green is the transportation phase. And what you see in blue is the material production phase. So you will see here that if you want to consider the entire life cycle into picture, the XLERATOR dryer has the lowest impact when compared to any of the other three options, and the paper towels have the highest impact. And where is that impact coming from? It's the blue and the red. It's the material extraction stage which causes it, which makes it not so eco-friendly, and the manufacturing of paper which makes it not so eco-friendly. But if you were to take just the accelerator dryer and the standard electric dryer, you will see the yellow part, the usage phase of the standard electric dryer is much higher because it is not energy efficient. But if you were to use an energy efficient hand dryer, it has the least environmental impact. So you can do comparative LCA studies like this. So that's what I wanted to share with you. So this is just some case studies that we have time to discuss today to highlight some of the applications and benefits of LCA. The last part of our presentation is really what LCA is like from Greenco perspective. And what you see here in the slide is the different credits. Now, how Greenco has been designed is such that 30% of the points are given for your systems and 70% of the points are given for your actual performance. So we are encouraging companies to, through Greenco, Green Company Rating System, to have very clear targets. Credit 1 talks about your targets. What kind of targets do you have to do a life cycle assessment study of your product? Credit 2 talks about life cycle management. Now, life cycle management has been a common tool. 3M, Volkswagen, and there are lots of other companies that have been using life cycle management. It's also defined by UNEP and CTAC as a business management approach that can be used by all types of businesses in order to improve their sustainability performance. It can be used to target, organize, analyze, and manage product-related information activities for continuous improvement along the product life cycle. So let's say you were to consider mobile phone manufacturer. So the product is first designed and developed, raw materials are extracted, selected, procured, supplied, then the mobile phone is manufactured, marketed, packaged, and distributed, and then it is retailed, purchased, used, and serviced, and finally it is disposed or recycled. So what a mobile phone manufacturer needs to do is to have life cycle management approach to understand at each of these stages what is the impact on the environment. How can the company come up with strategies to reduce that impact at each stage? So that's what we are encouraging companies to do through Greenco. And the third credit is for your actual life cycle assessment study that you do. The fourth credit is around how you reduce the environmental impact of your product after doing life cycle assessment study. The fifth credit is for your environmental product declaration. And the last credit, we give companies points for participating in external partnerships like CII is building a national level data set on life cycle inventory. So how have you contributed as a company? That's from a Greenco perspective. These are some very important resources. The presentation is going to be shared with you, so you will have access to these resources. We have a website, but there's also a Hitchhiker's Guide to LCA by Hendrik Baumann and Anne-Marie Tillman, which is a very good book for beginners for LCA. We have the American Center for Life Cycle Assessment, where I've taken some of the photographs and information from. You have Eco-Inventive Center's website, the organization we are partnering with. We also have International EPD System, Enviro DC, which does environmental product declaration. So I've saved some links of where you can get more information on LCA. So that's all I have right now. So I thank you all for participation. I also request open the forum for questions. So if you have any questions related to the presentation, please feel free to type in the chat box, and then I'll read out the question and then try to answer it to the best of my ability. So please, I open the forum for questions now.